Okay, so this video is going to go over how we maximize utility. What we've done is I've drawn a diagram here with showing our consumption space, and we've drawn the budget line and the indifference curves, a set of indifference curves for a consumer on the same axis. We can do this because when we introduced the budget line, we saw that we had quantities of the two goods on the axis. So here I'm going to use my favorite goods, Diet Mountain Dew and pizza. So if we're talking about a budget, a consumer having a budget, then for their budget line, the budget line would be drawn on a graph where on the axis you'd have the quantities of the two goods, Diet Mountain Dew and pizza. And then indifference curves are preferences over bundles of those same goods. So indifference curves were drawn on a graph where we had Diet Mountain Dew and pizza, the quantities of the two goods on the axis. So because we can actually legitimately draw indifference curves and budget lines on the same graph. It's why you have to pay attention to what we have in terms of the variables on the axes to see if it's legal or permissible to draw two different types of curves on the same graph. We can do that here. We assume that consumers maximize utility. That's the assumption we make in economics. And whether that makes perfect sense or not, well, we're assuming that consumers are trying to do the best that they can. And if you want to ask, well, why would you, do you really want to try to maximize utility? Well, one way to think about it is to turn around and say it otherwise. If there is some way you could take the money that you have and spend it in a way that makes you happier, who doesn't want to be happier or more satisfied? If there's some way you could feasibly change how it is that you're spending your money and you'd be happier, why wouldn't you make yourself happier? And that's sort of, I think, probably the best logic behind it is why it is that we assume that consumers are going to maximize utility. They're not going to stop adjusting their behavior until they've maximized utility. So how would you go about doing this? Now, you could handle this mathematically. There's a mathematical treatment of this. If you know calculus, we're assuming that the consumer is going to try to maximize utility subject to a budget constraint. This is a problem that mathematicians in studying calculus solved many hundreds of years ago. We know very well how you go about solving this problem. It's a constraint optimization problem. And so if you're familiar with calculus, if you're familiar with Lagrange multipliers, a technique used to solve a problem, you could do this problem in that fashion. Take the partial derivatives of the utility function and solve that Lagrange multiplier problem and calculate this solution that way. We don't assume that you've had a calculus, so I was just mentioning the optimization way to do this if you've had calculus. If you haven't had calculus, then let's try to look at this graphically and reason our way through this. And what we'll do is we'll give you an argument as to why C is going to be the point where that maximizes utility, and we'll do this sort of by looking at other points along this budget line and ruling them out. Oh, there's one thing I want to say before I actually started the points on the budget line. A consumer could also spend less money than their budget. They could be at a point inside the budget line. That might make sense in one way because you might think, oh yeah, well, wouldn't you want to save? Okay, perhaps, but the way we're handling the budget line, and since this is a budget line looking at a given period of time, as I said in the video when introducing the budget line, the way to think about the income isn't necessarily income as much as like the amount of money that you've determined that you have available to spend this period. So you've already decided how much you want to spend, how much you can afford to spend, and how much you're going to choose to spend. Once you've decided how much you're going to spend this period, then there's no reason not to spend it all. Because if you do want to save, well, then the amount of income that you've decided you're going to spend this period already allows for some savings. So if there is savings in there, then we've already handled that. We're not going to worry about the savings choice here. So if you leave aside the savings part of it, you can realize, okay, then if more is preferred to less, if both of these goods are goods, you're going to want to spend all of your money. So first thing you're going to want to do is spend all the money that you've decided you have available to spend this period. Okay, so that's going to put you on the budget line. We've ruled out any point inside the budget line because you can always buy a little bit more of both goods if you're at a point on the budget line versus a point inside the budget line. So more is preferred to less rules out all the points inside the budget line. How about the points on the budget line? Okay, let's start with A. Point A here is where the indifference curve with the utility level U1 intersects the budget line. Is this consumer maximizing utility at point A? Well, to maximize utility, you would like to get to the highest utility level indifference curve that you can reach, given that you are you're constrained to be on the budget line. Your budget line is a constraint. You can move up or down the budget line here, but you can't go beyond the budget line. You're constrained. You can't spend more money than you have available. And we just said you're not going to want to spend less money than you have available. So if you're at A, would you want to stay at A, or would you want to adjust your consumption? Well, the indifference curves that lie to the northeast represent higher utility, so U2 represents a higher level of utility than U1, so you can move along the budget line and get to a point like B. B's on indifference curve U2. It's got to represent a higher level of utility. So A cannot be maximizing utility. How about point E? Well, if you're up here at point E, that's not going to be maximizing utility either, because you're on budget line U1, and we can see that D is on budget line U2, and that's a higher level of utility. So D is clearly affordable and gives you a higher level of utility than E, so E can't maximize utility. So now we've ruled out E and A. And in fact, we've actually ruled out all the points down and to the right of point A and all the points up and to the left of E, in addition to ruling out those points. Okay, how about B? Would a point like B maximize utility? Well, no, because you look at C. C's over here and is on indifference curve U3. It's on the budget line. It's on a higher indifference curve. If you move up and to the left, if you move up towards C, you'll be getting on a higher level of utility than you have at point B. So point B can't maximize utility. Similarly, D is not going to maximize utility because C is affordable, gives you a higher level of utility. You move, and so if C is affordable as higher level of utility, D is not going to maximize utility. So we've ruled out D and B. So now we've ruled out the budget line here. Well, it turns out if you think about graphically what we're doing down here at points A and B, the reason we said if you think it through, the reason you weren't maximizing utility at point A or B was that the budget line is steeper than the indifference curve. All right, so at point A here, here's the budget line, and it is steeper than the indifference curve. So you can move up or down the budget line, and when the budget line is steeper than the indifference curve, when you move up the budget line, you've got to be getting to a higher level of utility indifference curve. And so that would still be the case here. At B, the budget line is steeper than the indifference curve. Now let's come up here at points E and D. You're not maximizing utility there because the budget line is flatter than the indifference curve. If the budget line is flatter than the indifference curve, then slide down and to the right along the budget line, and you've got to be getting to a higher level of utility because you're starting at a point like E or D, and where the indifference curve is steeper than the budget line, then if you slide down to the right along that budget line, you've got to be getting to a higher level of utility indifference curve. Because again, you know there's got to be a budget, there's an indifference curve just a little bit, at least a little bit to the right of D here, that's going to have to represent higher level of utility because the indifference curve is steep there. So C is going to be the point that maximizes utility. How can you see that? Well, because in one point, what we said down here is that if the budget line is steeper than the indifference curve, move up and to the left along the budget line. And if the budget line is flatter than the indifference curve, move down and to the right. At C, the budget line is neither steeper or flatter than the indifference curve. At point C, the budget line is tangent to indifference curve U3. Tangent means they have the same slope. And so indifference curve U3 comes in here, and it actually coincides with the budget line at one point and exactly one point. And at that point, the budget, the indifference curve has the exact same slope as the budget line. So that's a tangency point. So it turns out that tangency is what's the tangent point is going to maximize utility. If you're mathematically inclined, you might not be very impressed with the. This is sort of like a graphical argument I'm giving here as to why C is going to maximize utility. Well, there is. We know this is true. We know this from the mathematics of all this. So this is a little bit of I'm telling you a verbal story here to get us to what's really a mathematical point, but. You'll sort of have to trust me that the tangent point is the point that's really going to maximize utility. And again, the reason for that being is that it's at point C where they're tangent that the budget line is neither steeper nor flatter than the indifference curve. So our rule in terms of how to adjust consumption to raise utility isn't going to apply here because it's neither steeper nor flatter, so there's no place to go. And it turns out that's actually going to maximize utility. We could look at a point like, say, F here that would be on indifference curve U4, and the consumer would clearly like to get to a point like F on U4 because that would represent a higher level of utility than you have at U3. But F's not affordable. So F can't maximize utility because it's not affordable. It is a higher level of utility than you can get at point C with U3, but it's not affordable. So point C, the tangency point between the indifference curve and the budget line, is going to be the point that maximizes utility for the consumer. So a utility maximizing consumer is going to be here. And we can give here like a very definite and concrete prediction of exactly how it is we think that a rational consumer who's trying to maximize utility is going to behave in the context of this model. And that's really what we want to try to be able to do in economics. Describe how it is that somebody in one of our models is going to behave and show that it's also consistent with rational behavior on their part. And so a utility maximizing consumer is going to want to be at a point like C, which is the tangency point. And as you'll see in the PowerPoint slides, since it's a tangency point, that means since the slopes are equal and we know what the slope of the indifference curve is and we know what the slope of the budget line is, well, we can get an important what we call tangency condition out of this out of the solution of the utility maximization problem. But that's covered in my PowerPoint slides and also in the book. All right, so that's utility maximization.